Good morning, friends. In the last lectures, we have studied the part regarding the reactions of the quinolines. In that quinolines, we have taken the starting materials as the quinolines, and that starting materials reacted with the Br2 bromine. The reaction is halogenation reactions. So in that reactions, bromine is taken as the Br2 along with the concentrated S2SO4. The temperature of the reaction is the 75 degrees centigrade. So we will get the products at the fifth positions and to the eighth positions. Means at the fifth position bromine is added, and at the eighth position bromine added. That means the five bromoquinolines and the 8 bromoquinolines. These are the two products of these reactions. Next reaction is we have studied in the last lecture, the nitration reactions. In that nitration reactions, we have taken the starting material as the quinolines. Along with that quinolines, we have taken the reaction condition that for the nitration, we know that the nitrating agent is the concentrated H2SO4 and concentrated HNO3 along with the 0 degree centigrade temperatures. So we will get at the fifth position and at the eighth positions nitro groups get attached. So we will get the product that is the 5 nitro aniline quinolines and the 8 nitro quinolines. These two positions, fifth and eighth positions, are favorable for these reactions. Next is the amination reactions. In the amination reactions, starting material is the quinolines. Aminating agent we are used are the sodium nitrite along with the liquid ammonia and the KMnO4 along with the two different temperatures. So first we have taken the minus 66 degrees temperature, and second we have taken the minus 40 degrees centigrade. Means that the quinolines react with the sodium nitrite in liquid ammonia, and the KMnO3 at minus 66 degrees temperature gives the product at the 4 amino quinoline as the products, 2 amino quinoline as the products. And when the quinoline react with the sodium nitrite along with the liquid ammonia and KMnO4 at the minus 40 degrees centigrade, we will get at that time we will get the 4 amino quinoline as the products. So we get the two products, that is first product at the 2 position 2 amino quinoline, second at the 4th position that is the 4 amino quinolines are the two products of amination of quinolines. Next reaction which we have studied in the earlier lecture is the reaction with N-butyl lithiums. So in the N-butyl lithiums, quinolines along with the reaction condition that is N-butyl lithiums and along with the two materials that is the base, and at the room temperature we will get the product that add on the butyl groups at on the second position, that is 2-butyl quinoline is the product of these reactions. So N-butyl lithium is a strong base. It absorbs the protons from the second position, very strong base, and create the positions and attach their butyl group, and we will get the 2-butyl quinoline as the product of these reactions. Next reaction is the reaction with the reducing agents. In the quinolines, either the pyridines or the benzene ring can be selectively reduced. So in this case, reducing agents are those agents which reduce the ring systems, reduce the double bond. So in case of the quinoline, only nitrogen containing pyridine rings double bonds is going to be reduced. Means two double bonds of this system is going to be reduced. So we will get the 1, 2, 3, 4 tetrahydroquinolines, because the reducing agents are those agents which reduces the or which increases the hydrogen atoms or decreases the oxygen atoms, or which increases the carbon as the product. So these are the various types of reactions. Okay. So next one is the This part we have covered in the yesterday lecture. So next reducing agents, that is the S2PT, hydrogen peroxide 2PT, along with the CS3OH methyl alcohols. So it will be selectively reduce the benzene ring attached with the pyridine rings, because these are the selective reducing agents. So these reagents selectively reduce the benzene ring attached to the pyridine ring to get the 5, 6, 7, 8 tetrahydroquinoline as the product. 5, 6, 7, 8 tetrahydroquinoline as the product. Next one is the quinolines. So quinolines, lithium nitrates. Quinolines 1,4-dihydroquinolines. So in this case, nitrogen attached with the hydrogen atoms and get the alkane system, that is 1,4-dihydroquinoline as the products. Next one is the quinolines react along with the lithium aluminum hydride, and in presence of the diethyl ether as the reagents selectively reduce the bond which present at the nearest to nitrogen atom. So which bond it breaks? It selectively breaks only It selectively breaks only the quinoline bonds. So this is all about the reducing agents. So we have the next one reducing agent is the lithium aluminum hydride along with the diethyl ether. It is selectively reduce the adjacent nitrogen bonds and give the product 1,2-dihydro. That is, position is the 1,2 positions. So there's 1,2 positions, double bonds break, and there is formations of the new compounds, that is 1,2-dihydroquinoline as the products. So these are the reducing agents which are we have studied. There are 4 types of reducing agents. One is the lithium aluminum hydride, selectively reduces the 1 and 2 positions. Second one is the lithium reagent, and along with the ammonia, this selectively reduces the 1 and 4 positions, means the 2 or 3 positions form the compound 1,4-dihydroquinolines. And the S2PT along with the methyl alcohol is selectively reduces the 5, 6, 7, 8 positions double bonds and form the 5, 6, 7, 8 tetrahydroquinolines. And another one is the selectively reduced bond is the S2PT CS3OH, that is quinoline, selectively reduced 1, 2, 3, 4 tetrahydro compounds. So these are the selectively reductions takes place in the reactions, and this is the reactions of the quinolines. Next one is the reaction with the oxidizing agents. So in this case, quinolines react with the anilines along with the KMNO4s. So KMNO4s, so this is the oxidizing agents. We know that the KMNO4 is the oxidizing agent. Oxidizing agent means the compounds which gives the oxygen atom to the compound, or remove the hydrogen atom to the compounds, or give the electron to the systems. So it is called as oxidizing agents. So in this case we are using KMNO4 is the oxidizing agent. So it oxidizes the position, that is the 6th, 7th positions with along with the acetic acid, or it oxidizes the by removing the ring structure and converting it into the COOH groups, that is pyridine 2,3-dicarboxylic acid as the products. So you remind this by doing the practice. Do the practice of these compounds many times, so can easily understand and easily remind these chemical compounds reactions. Next one is the quinolines react with ozones. So ozones are the oxidizing agents. It is also breaking the compounds, and breaks it form there the oxygens. from the breaks from that position. With that, there it form the C double bond O groups, means it breaks from the that is fifth and sixth position break, and seventh and eighth position breaks. So at the sixth position there formation of one aldehyde group, and seventh position there is formation of one aldehyde group. At the fifth position there formation of one aldehyde group, then at the eighth position there formation of the aldehyde group. This is only possible because of the oxidizing agent, that is ozone. So we will get the two compound, that is cryosine and glycine, and one is the pyridine 2,3 dialdehydes, pyridine 2,3 dialdehydes. So these are the two compounds forms. Next one is the reaction with the CS3COOH, means the peroxides. COOH means the peroxide. So this peroxide is also best oxidizing agents, having the 3 oxygen atoms in that compound. So it will easily give the 1 oxygen atom to the nitrogen atoms. Nitrogen having the lone pair of electron, which is not involved in the delocalization. It is a free lone pair of electrons, so it is attached on the that for extra oxygen, that is peroxide oxygen atoms, and gives the quinoline N oxides as the products. So quinoline N oxides as the products we will get after the reaction with the oxidizing agent, that is the peracids. This is all about the oxidizing agents. So we have studied the 3 oxidizing agents, oxidation reactions of the quinoline, one with the alkaline KMNO4, second one is the O3, and third one is the peroxides. So we know you always keep in mind that the KMNO4 is a very strong oxidizing agents. It gives the different oxidizing product at a different temperatures also. So here is from the acidic groups, we break the compound from the 5th and 6th positions, and at the 5th position there is one carboxylic groups, and at the 8th position there is another carboxylic groups. Second one is the oxidizing agent is O3, that is the ozone layer. This also break the from the 5th, 6th and 7th, 8th position, and at the 5th, 6th position there formation of one aldehyde group. At the 6th, 7th position there is a formation of one aldehyde group. At the 5th and at the 8th group position there is a 2 aldehyde groups. So the pyridine 2,3 dialdehyde groups is forms. Another one is reagent, that is the acid, carboxylic acid peracid. This is also can give the oxidation at the nitrogen atoms. So we will get the product quinoline N oxide as the products of these reactions. Next is the reaction of isoquinolines. The one is the halogenation reactions, Br2AlCH3. Halogenation takes place at the 5th position and at the 8th position. So we will get the product 5-bromo isoquinoline and 8-bromo isoquinoline as the products. So it's the halogenation reaction of isoquinolines. AlCl3 is the Lewis base. Lewis base facilitate the halogenation reactions by attracting or making the bromine as the more and more electrophilic in natures. So this is all about the reaction. Next one is the nitration reactions. So in the nitration reactions, the material starting material is the isoquinoline, which is react with the nitrating agents. So we all know that because we have studied in the pyridine oxide, we have studied in the quinolines. Now we in the isoquinoline, we are also studying the nitration reactions. So you know that the well-known nitrating agent of the reaction is the concentrated H2SO4 and concentrated HNO3. So these two reagents are used for the nitration. So we will get the product at the 5th and the 8th positions, means the 5th nitro isoquinoline as the 90% major product, and the 8th nitroquinoline as the 10% nitrating agent. Next one is the amination reactions. In the amination reactions, we studied the amination reaction at the pyridine N oxides, and we have studied the same amination reaction in case of the quinoline also. And now we are studying in case of isoquinoline also the amination reactions. In the 3 reactions we are used the same reagent, that is the sodium nitride along with the liquid ammonia and KMNO4. Yes, the conditions is here, that is the minus 45 degrees centigrade, only one conditions. In that condition we will get the product side, the first position, that is the we will get the product 1 amino isoquinoline as the product of the reactions. Next one is the reaction with the n-butyl lithium at the room temperature. So we will get the product at the first position, that is butyl group, and butyl group get dehydrated, get the L-butyl isoquinoline as the products. Next one is the reaction with the reducing agents. The reducing agents are the S2PT, CS308, S2PT, 2 normal SCl. So reductions takes place at various positions by using the different reducing agents. When we use the CS2PT, CS28, the reductions takes place at the 2 and 3, 1 2 3 4 positions. Again the 1 2 3 4 tetrahydroisoquinolines. We will react with the S2PT, 2 normal SCl. The reductions takes place at the 5 6 7 8 position. We will get the product tetrahydroxyisoquinolines. When we react the isoquinoline with the lithium NS3, that is the lithium metals, the reaction takes place at the 3 and 4 position, that is 3,4 dihydroisoquinolines. When they react with lithium aluminum hydride, the reaction takes place 1,2 position, that is 1,2 dihydroisoquinoline as the product. So this is all about the reactions. In the next lecture we will complete these topics along with some remaining reactions. Thank you very much.